Hi, how is everyone doing? Good. Can you guys see my screen?
Yes, sir.
Very well. Should we start or should we wait for a few minutes? Saurabh, should we start or there are more people expected?
We can wait for a couple of minutes, then
Sure.
we can start.
So till we start, could anyone want to share what is your view? What are your expectations from this session? I know I've shared a small summary of what all we're going to cover, but is there something specific you'd want to know? Anyone? I think we have a very shy crowd.
Sir, we can start.
Okay. Did you all download Tableau for that matter? Have all of you downloaded Tableau? Or at least the Excel add-in?
Yes, sir, we did.
Okay, thank you so much. So my name is Harish Rijwani. I have 18 years of experience all in healthcare IT. I've worked with quite a lot of healthcare providers, primarily based in the US. Okay. And I'm going to try and share with you what is my understanding of what we can do from a healthcare analytics perspective. There are a lot of things which we can do. But first of all, I probably start with a little bit of the basics, wherein what I would want to know is what is your understanding of the hospital workflow, and I'd like to keep this an interactive session. So if somebody can share what is their viewpoint from a patient perspective, what happens in let's say a couple of minutes, just take a minute or so and explain what is your understanding of the hospital workflow. Anyone wants to give it a shot? Just think of it from a patient perspective. What happens? What are all the touch points that you see? Anyone? Anybody wants to give it a shot? Yeah. Yeah, Dhruvi.
Yeah, so if a patient has been
Voice is kind of breaking. I'm not sure if it is for me or for everyone. I can't make out what you're saying. I'm sorry, I can't make out what you're saying. Can anybody else make out what she's saying? Anybody else?
Yeah, I'll give it a shot.
Sure.
The patient is taken in and they run basic tests on them maybe to check out if they actually need to be admitted in the hospital or not.
Right.
Then if the patient has to be admitted, then there are a series of forms which they have to fill depending on how bad the condition of the patient is. Maybe a room is assigned intensive care or a normal ward maybe. Then they're give even after admitting them, maybe there are a few tests run on them to kind of see how uh, what do you say, like if there are any further advancements in their illness or something, and how they can cure it. Medications are given, and a very common thing is like they give that saline thingy, and till the patient is till they feel like the patient is has recovered enough and does not need to stay in the hospital anymore under observation, then they discharge them maybe, which has a whole different set of formalities. But yeah, that is about it, I think.
So yes, that's kind of a gist of the entire workflow. Normally, if I have to explain this, I take 90 minutes, but I don't think I'm going to spend that much time explaining this entire workflow. But you did cover quite a lot of the gist. Not anybody, I mean, practically speaking, nobody likes visiting the hospital, whatever be the situation. That's the last resort, which is why even now, I mean, especially now, people don't really want to visit the hospital. But sometimes you are left with no option. So what do? You take an appointment. Either you call the hospital or you just directly go there and check what are the appointments possible for a particular doctor. If you don't know the doctor, they'll probably tell you that the front desk person will tell you that you visit XYZ clinician. And based on that, they're going to ask some information from you. At each touch point that you see, you're capturing some data. You're capturing certain kind of information. At the time of appointment, you're capturing the name of the patient. You're capturing the basic information. Probably they might ask you for insurance details, just the insurance ID or the number for that matter. Ultimately, quite a lot of information is captured at the point of care, because at the point of care, what is happening is you have quite a lot of information in terms of the physician notes, the nurse notes, your lab results, your radiology results, any other medication that were given to that particular patient. In the end, at the time of discharge as well, there is quite a lot of information which is captured. Okay. So where do you think, when you look at this, right, when you look at the entire flow, where do you think you get that data from? Any idea where do you get this data from? You see this paper, any place where you will get electronic data? Anybody?
No idea.
No idea. You've heard of electronic medical records, EMR systems? Yes, somebody speaking. Okay. So I'm not sure if you've heard of EMR system. It's like an application where using which the hospital can capture information electronically. So like on Facebook, you log in and you capture some information. I mean, rather you're putting data over there, but in a way, it's like a system. If you're studying somewhere, you might have an online portal within your college or your organization. If you're working someplace, but definitely you might be using some tools and application within the organization, right? You're capturing some information electronically. So within the hospital, you have electronic medical records. You have electronic health records. Instead of paper, they are electronic. So whatever you can capture on paper, you can capture it electronically. That is where you get this kind of information. Okay, you're capturing this information. Now, these are your source systems. In the sense, these are applications or Epic. You might have. I'm not sure if you. I don't. I'm not sure if you've heard of any of these systems. If you search for them, these are big applications. Okay, Epic has a more than 50% market share of EMR systems within hospitals. You can search for that. Quite a lot of hospitals are moving towards Epic. You have Meditech, you have Cerner. These are the top 3 EMR systems across the globe. Okay, then you have Sunquest, which is specifically for lab. Teletracking is used specifically for bed management. GE systems you might have heard for diagnostics and radiology. Right? There are quite a lot of other systems which are there in the market, but I'm just listing down some of the key ones. So whenever you want to do any analytics, whenever you want to analyze some information, right, the first step is to identify the source systems. Like I mentioned, normally what I do is I take 90 minutes to explain the entire business workflow. So what is important for you or anybody who wants to analyze this information is to understand the business workflow. So first thing is to identify these source systems. Whatever be the scenario, whether it is a hospital, whether it's the pharma industry, whether it is life sciences, whether it is the insurance world, you have to identify where are you getting your information from. It cannot be paper, because you, the computer really does not understand the text on paper. You can still try and convert that paper notes into electronic, but it's going to be very difficult in many situations. So you need electronic information. So which is why the first step is to identify the source systems. The second step is to extract that data. When I say extract, you might have seen you using Excel files, CSV files. That is a way of sharing information. Within healthcare, you have specific standards. In the sense, the way I am talking to you in English, healthcare uses specific standards to communicate with each other. You have multiple systems. You can have an Epic system talk to a Meditech system. So you can just think of the way India works, right? In India, you have so many different languages across the world, across the entire region. If you go to the north, you will find people speaking very good Hindi. If you go to Bangalore, you'll find people speaking English. Everybody literally speaks English in Bangalore. If you come to Maharashtra, if you go to the inner places of Maharashtra, you have to know Marathi. Okay, if you go to Gujarat, you better know Gujarati. Though everybody understands Hindi as a dialect, but that is a way in which communication happens. In the same way, for these source systems, you can talk to them using HL7 or EDI. Okay, HL7 is a form of sending data. It's a standard. Okay, for now, I mean, at this point, I can just explain that much. Otherwise, I can get into a lot of details. All right. Next is something we need to clean that data. So I'll ask you one more question. What are the units of hemoglobin? Anybody knows? Or what is the range for hemoglobin? You know what is hemoglobin, right? CBC test. Within CBC, you have hemoglobin. Any idea what are the units for hemoglobin? Anyone?
Something around 12 to 15 grams per deciliter, I think.
Yes, grams per deciliter. So that is for, I think, for a male. For female, I think it is, I think one of them is 10 to 11 to 13 or something, and then 12 to 14 or something like that, if I'm not mistaken. Yeah, that is for a male and female. Now here you told me the unit says gram per deciliter. But in some cases, what might happen is you will get that data depending on the kind of test has been done, right? Somebody might give milligrams per deciliter, somebody might give grams per liter or milligrams per liter. In that sense, the unit changes. And if you are getting that data in a different format, in a different structure, you need to standardize this. Otherwise, what you're going to end up comparing is 12.1 to 0.12, which will not make sense, which will not give you the right output. Okay. So from that perspective, it is important to standardize this information, to standardize this data. Another example, which might be very easy to relate to. You go to a doctor, one physician tells you a patient to do a sugar test. Another physician tells another patient do a glucose test. You know, there are so many different names which indicate the same thing. You have your blood sugar level, you do fasting, you do PP, all of them mean the same thing. So if, yeah, anybody has a question? So if you need to really create some information out of this, you need to standardize this data. You need to clean this information. Okay. After this standardization, what you have to do is you have to put your data into a data warehouse. For that, we need to create a logical data model. It's more like a structure. It's a structure which you can think of it like different drawers in your cupboard, wherein you're storing some information. In these all of these drawers, you have different kind of information which is there. So you're storing that information. Okay. Then you have an integration layer. Basically, you can think of this as match the column. These are all tools which are used within healthcare. Mirth is an integration engine. Like I said, it is match the columns. Here you see these front end systems. You see an application. Here you see a drawer, right? You see that drawers in the sense that, like I said, it is a tabular structure. You can think of this as different tabs within one Excel sheet. Yeah, within an Excel, you have different sheets. Each of them is holding, one of them is holding billing information, the other is holding a lab information, the other is using any other clinical information. So think of it in that sense. And this mirth is just moving that data into the specific locations. And finally, what we get is this, your reporting and analytics. So quite a lot of people use Tableau for reporting and R and Python for analytics. Okay, you can do some level of analytics in Tableau, but primarily people use R and Python for your analytics. Understood this? I just wanted to give a brief because I can't really spend a lot of time on this because we want to do a little bit of hands-on. But any doubts, any questions? Oops. Cool, thank you. So I have this data. I have got the data. Okay, I have got my data over here. I've stored this data. Now what should I do? So I'm going to tell you a small story. Hopefully you will get the idea. All right. When you look at the story, we have a story of a lion and the clever fox. So the lion was sitting with the lioness, in the forest, and the lioness tells the lion that you have bad breath. So what the lion says, he said, I don't believe you. I'm going to go and check with others. So the lion roams the jungle, and the first animal he finds is a sheep. He asks the sheep, does my mouth smell bad? The sheep says, yes, your mouth smells bad. There is bad breath. Can you tell me what happened to the sheep? Any idea? What do you think that happened to the sheep?
The lion ate.
Yes, the lion ate the sheep. The sheep was eaten by the lion. Next, the lion met another animal, and this animal is very good at lying. So he told that your mouth smells like roses. What do you think happened to this animal? Was he spared? Any idea?
Quite possibly.
Not really. He was eaten by the lion. The wolf was eaten by the lion. Okay. Finally, he met a fox. So the fox deflected the question by saying that I have a blocked nose. What do you think happened to the fox? Any idea what happened to the fox?
No idea now.
No idea? Okay, he was spared. The fox was not eaten. So what the lion did that, I am going to hire you to help me find prey. Because the lion thought that the fox is very intelligent, he hired the fox to help him identify prey. And he told him that, okay, I am giving you data. The fox was given data of the jungle. So you see this warehouse. We had this data in a warehouse. He had information related to the jungle, the creatures, and all the happenings in the jungle. So the first thing the fox did was he used information of past 6 months and helped the lion identify the fact where all did he find prey. Okay, where is it that the past 6 months he found prey? Understood what he's done? He's just taken the last 6 months data and told him what is that information. Nothing more, nothing less. He just told him what has happened in the past. This is an example of descriptive analytics. Make sense? I am just taking data of the past and telling you what has happened. Got it?
Yes.
Very nice. Anybody has a question? Okay. Now, the next thing the fox did was using that same information. Okay, for the past 6 months, why did the lion miss a prey? Okay, he analyzed this data and found out why did the lion miss his prey. So here in this case, this is called as diagnostic analytics, where you're trying to answer a question why. Why did something happen based on the past information? Got it? So the first one was what has happened. Second is why something has happened or why something has not happened, which is why we're calling it diagnostic analytics. Okay. Next, the fox now looked at the data of past 6 months again and told him that based on the information that I have, I'm going to tell you where exactly will you find the prey. I will tell you the place and time because I know that the sheep comes to this particular location every day at 9 a.m. to drink water. So there is every possibility that you will find the prey over here. This is called as predictive analytics, wherein you're trying to find out what is going to happen in the future. Make sense?
Yes, sir.
Okay. And finally, what the fox did that because he knew that the sheep or any other animal is going to come at a particular location at so and so time, he dug trenches using which he can capture the prey automatically. So now what you see is that is called as optimization of prescriptive analytics. So these are 4 ways in which you look at analytics in terms of what has happened, why did it happen, what will happen, and how can you make it happen. This is based on Gartner's Ascendancy model. Okay, so here you can divide it into hindsight, insight, and foresight. Foresight is when you're looking at the future. Insight is something which has, again, these two, you can think of it as the same. Here you're just trying to answer a question. And here you're just saying that, okay, this is something which has happened. There's nothing you can do. You're just seeing the statistics. All right. So now I'm going to get into a little bit more detail in terms of analytics. If I tell you this image, what does this image depict? Can you tell me what do you see?
I see a fruit basket.
Okay. Basket. Okay, what are the fruits? The fruits are fine. Basket of fruits is fine, but what are the fruits? Can you recognize the fruits?
There are green grapes, bananas, apples, pears, and oranges.
So how did you decide that this is an apple, this is an orange, this is a grape, this is a banana, this is a pear? How did you decide that?
Because they look like
Yeah, how?
Because of their
things
shape
thought since we were
and
younger, I suppose.
color.
Yes, the shape, the color. Because when you were a child, when you were a kid, that's what you have been taught. Your mind has been trained in that manner. Your mind has got that muscle memory. Yes, the mind has. When you were in kindergarten, you were shown these images again and again, and you were told this is what an apple looks like. This is what a grape looks like. This is what a banana looks like. And that is where whenever you see an image of a banana, you are able to figure that out easily because it's there in your muscle memory. Now, if I want a computer to understand this, I have to use the same logic. I have to make the computer understand this. So what I have to do is I have to give that computer images. So these are all the fruits, like I mentioned. you know the shape and the size. Those are your characteristics. Like you said, it is red, it is round shape, it is heart shape, this is cylindrical, this is round and oval, it is green colored, it is small. So these are the characteristics of each of these fruits, based on which you are able to distinguish the apple versus your pear. Okay. What we call this, especially when this is labeled information, we call this as supervised learning. Like when in your childhood, you were shown images and then you are told that this is an apple. So next time when you see that image and you are tested, you are able to say that, okay, yes, I remember this is an apple. Okay, that is called supervised learning. When you have these labels along with these characteristics, this is known as supervised learning. So this is an example of classification. So what we are going to do is, before getting into classification, we're going to look at one type of classification. But before that, I'm going to explain to you what is regression. You heard of regression? Anybody? Any idea what is regression? You understood classification, right? Basically, you are trying to, based on an image, here I am trying to automatically label them. Okay. Tomorrow, if I give you, I don't give you this right hand side fruit name, and if I give you this characteristic, you should be able to tell that the first line is an apple, the second line is a cherry, third is a banana, last is an orange. You should be able to do that, right? I hope you understood what is classification.
Yes, sir.
Okay. Anybody heard of regression?
It has something to do with statistics, but I don't know the entire thing.
Okay. Just give me a second. In terms of regression, right? It started off by a person, a person named Francis Galton conceptualized this when he was analyzing the heights of members. He looked at a lot of information of 700 families, 700 odd families. He gathered that information and he found out that if the father's height is, if the father is tall, the son or the daughter's height is not really as tall as the father's height many a times. That is what he found out. He found out there is a relationship between those two. In school, you might have heard of this equation, y is equal to mx plus c. Okay, there is a relationship between two variables, y is equal to mx plus c. And let's not get into this. I'm going to, if you open this Excel, right? Let's open this Excel. You have this Excel. This is your prostate cancer Excel. Do you have the Excel?
Yes, sir.
Okay. In this Excel, I have copied the last two cells. I've copied these last two cells, last two columns rather, last two columns, and put it in a new sheet. Let me know if you have it. Have you copied this data? Let me know if I should move forward.
Yes, sir.
Okay. So now I have copied these two data sets. And what I'm going to do is just select these two columns, select the data, and go to insert. Within insert, go to charts and plot a scatter plot. So you see information like this. I don't want this. Do you see a graph like this? Did you guys get the scatter plot? Let me know if you're facing any issues. You have the scatter plot? You guys got this? Did you get the scatter plot? You let me know if you want me to repeat it.
We got the scatter plot. So
All right. Now what you do once you have the scatter plot, right click on any of the points and click on add trend line. And you'll see a straight line which is there. You see this straight line. Okay. It is a linear line. This is your regression line. What you see. If I display the equation on the chart as well as R square. All right. So I'm just going to increase the font a little bit. So what you see over here is you see a straight line passing through all of these points. In school, you might have studied this. You might have studied, especially in mathematics. I'm not in school, probably in junior college, if you took science. I'm pretty sure you all taken science. So you would have studied this. You would have seen this equation, y is equal to mx plus c. So here, this line is going to go and join this at this point. Okay, that is the intercept that you see. So you will see that it is going to go and join at a certain point, 0.0453 mostly. That is your intercept. Then this is the slope of the line, 0.0978. So here we are trying to find out the relationship between two variables and in terms of how they are related to each other. Okay. And this R square is basically telling you how good this line is a fit. If I look at it, right, ideally what should happen is all these points, the line should pass through all of these points. But that is not the case over here because you can see quite a lot of points which are away from the line. Okay, so in terms of statistics or basic analytics, what you see, this is not a good fit. Okay, that is what it really indicates, that the linear regression is not really a good example of this particular line. Okay, so this is what you call as regression. Just simply put, y is equal to mx plus c. Now, any questions till now? Let me know if you got the trend line, and you see on the right hand side, if you just select display equation on chart and display the R square value, you will notice what is the point. Basically, what we are doing is we are predicting this value of fractal dimension based on the symmetry. We are trying to find out in terms of prostate cancer, when you look at this data, right, you have the radius, texture, perimeter, area, and all these elements. I've just taken two variables, symmetry and fractal dimension. and I'm trying to predict what would be the fractal dimension based on symmetry. That is what this line is indicating. Y is equal to mxp, where y is this particular common fractal dimension, and x is symmetry. So if I put a value of this equation over here, right? If I put 0.0978 into this plus 0.453. Okay. So here what you're getting is 0.053. Here I'm getting 0.466. Here, let's see what we get. Over here also I'm getting 0.466. So this is not really what am I done? Okay, I've forgotten to put a 0.0. Yeah, so now this looks better. Okay, so you see a little difference between the two values. That is what is called as an error. Okay, you're still predicting a number close to this value. You are just trying to find out the fractal dimension based on this symmetry. And I can do this for this entire sheet, by the way, to tell you what is the difference. But I don't want to get into that. I just want to give the concept that this is what is called as regression. Here you're predicting a number. You are not predicting or classifying, you're predicting a number. Make sense? To a certain extent. You'll probably see, if you're seeing this for the first time, you might find it a little confusing. Any questions?
So,
Okay. All right, thank you so much. Now let's go back to this sheet. Now here, right, I see a column over here called diagnosis result. And what this is doing is, let's say I copy this over here. I copied this over here. What do you think this M and B indicate? This is prostate cancer. So what would M indicate? Any idea? Sorry, if you're saying malignant, that is the answer. If you're saying B is benign, that is also the answer. I didn't understand what you were trying to say though. So you have M indicating it is malignant, then B indicating benign. So I have data which is telling me based on this information, I have your values as malignant or benign. Now tomorrow, and I have 100 records of this, right? 99 rather. 99 rows, rather 100 only. Yeah, 100. Sorry, 100. So I have 100 records wherein I have all these elements. When I do a scan, when somebody does a scan of the prostate, you know the radius, the texture, you know all these values. And based on that, now for anybody else who comes in to do this, I want to find out what is the possibility of the diagnosis being your malignant or benign. So in this case, I cannot use regression because in regression, we were predicting a number. We were predicting this value of fractal dimension. Here we want to classify it. Yes. This is an example of classification. So I'm going to add another column over here. And I'm going to convert this M into, so if I have M, I'm going to make it 1. If I have B, I'm going to make it 0. Okay. Can you do that? You have to make the M as 1 and B as 0. Let me know once you're done or if you're facing any issues. The reason why I'm doing this is because the computer does not understand text so easily. You need to convert them into ones and zeros. Now the other element which I wanted to show you, I am selecting this columns and I'm doing a conditional formatting where the value is equal to any. So first of all, just let me know if you are able to convert that diagnosis result into 1 and 0. If you're finding it as an issue, just select the column and do a Control H, using which you can change all M to 1 and B to 0. Just use Control H, change all M to 1 and B to 0. Let me know once you're done, or if you have any questions, queries, do let me know.
So I got disconnected for a while. Can you just answer zero?
Yeah, so what I did was I did a filter. Okay, I filtered the data first of all. I have added another column, the same column. I copied this over here. Okay, so wherever, one second, I'll just show it to you. What I've done is, if the diagnosis value is M, I am putting a 1. Okay, I'm putting a 1. If the diagnosis value is B, I'm converting that B into a 0. For all the B's, I've converted it into 0. This is what I've done. Another way is, I just copy this. I'm just going to copy it for my reference. Another way is just select this column, do Control H, change all M to 1, change all B to 0. That is also an easier option. That way, your life is easy.
Okay.
Okay, let me know when you're ready and we'll move to the next step. Any doubts, anybody? I hope you're following. I didn't. Can you put your question in the chat? I didn't understand what you just said. All right, thank you so much. So the next step I did, right? I selected this data. You see the columns other than your diagnosis result. I have selected that and I have added a conditional formatting wherein the value, when it is equal to NA, I have filled it light green or whatever you want, right? I put it yellow, you can put it yellow. So this is when your step of cleaning comes in. When we talked about this, right? In the slides we saw this. The step when you're cleaning the data. This step, this is what is important over here. You see this NA. You see there are NAs over here. Okay, you can clearly see the NA in these two columns. So we need to either delete those rows or we need to see what value we can put over here. So deleting that data doesn't really make sense because we don't have so much data as well. We have only 100 records. So what we're going to do is when I select this column, I see the average value is 0.12459. So I'm going to put the value as 0.12. So if you see the average, I'm going to put that average as 0.125. Okay. Wherever there is an NA, I'm going to put the value as 0.125 because I took the average of this entire column. This is one way of feeding in data which is not present. You don't have that data probably because it was not captured. So we are entering that value as you see at the bottom in Excel 0.125. Okay, so I'm putting that value over here for any 0.125. 0.125. Okay, I put that value because I don't want to lose the data. In same way, in fractal dimension, I have my data as 0.0648. Okay, so I'm going to put that value as 0.065, rounding it up. 0.065 for any. 0.065. 0.065. So you can do the same. So we have cleaned the data to a certain extent. It's a very basic step of cleaning, wherein I have filled or entered information for the data which is missing.
So can you please repeat the steps?
Yes, sure. Let me repeat it. So I have compactness. When I select the column of compactness, I see the average 0.1245. Okay, 125. I can take it as 1.125. Understood till here? I have taken an average value. I see this average at the bottom when I select this data in Excel for compactness. I basically want to replace this NA which is there in my data indicating that I don't have this information. I want to replace this NA because I do not want to lose this entire row because I have this one column which is missing. One value in this column is missing. So I take an average of this particular column which is 0.124. So I'll take it as rounding it off 0.125. Clear?
Yes.
Now I will select the NA in this particular column and make it 0.125. 0.125. 0.125. Okay. Got it for compactness? Should we move forward for fractal dimension?
Yes, sir.
Okay, the same way for fractal dimension, when I take the average, I see the value at the bottom, 0.0648. Okay, so I'm going to take it as 0.065. And wherever there is an NA, I'm going to make it 0.065. 0.065. That's what I've done. So now I should not have any NAs in my data. I should not have any information which is missing in my data.
Yes, sir.
Okay, should I move forward? Okay, so my columns are right from
Sure, sir. Yes.
radius, texture, perimeter, area, smoothness, compactness, symmetry, fractal dimension, and diagnosis result. This is what is my information that I have. The last column in your data should be your diagnosis result. That is the structure in which your data should be. What we are going to do is we are going to use something called as logistic regression. Okay, and just to give an idea, let's go fast. In case of logistic regression, like in this is called a linear regression because you're drawing a line like this. Okay, in case of logistic regression, your data is such you have information like this, 1 or 0. Okay, will I lose weight, yes or no? Is this prostate cancer, yes or no? 1 or 0. If I use linear regression and I draw a line, the challenge over here is going to be that probability cannot be more than 1 and probability cannot be less than 0. Because what you're going to predict is the probability, the chance of you losing weight or the patient having prostate cancer. So it will give you a number, 90% chance, 70% chance, 50% chance. So that number cannot be more than 1 or cannot be less than 0 because probability cannot be less negative nor can it be 200% chance, right? That is not possible, which is why this line becomes an S-shaped curve. This is called as your logistic regression, wherein you have data in this format, 1 or a 0. Okay, so that is what we are going to do in this case. In case of prostate cancer, that is what we are going to do, malignant or benign. So here you have to go to add-ins. You have to go to real statistics. If you do not see that add-in real statistics, I'm hopeful you have all installed this real statistics add-in. Otherwise, you might have to try this later. Okay. So if you have this real statistics add-in installed, click on this data analysis tool. Go to regression. Here you'll see logistic and probabilistic regression. Click on that. I click OK. I have to give my input. So the thing is, like I mentioned, the last column has to be the result, that is your 1 or a 0, and the other values can be there as is. So here I'm going to select all these columns. I'm going to fill this. So it selects the entire range, and I'm going to put this new. So I'm not going to spend a lot of time explaining all of these elements, but I'll give you a brief idea. How many of you have this real statistics add-in and do you see this? Have you installed this real statistics add-in? Anyone installed it?
So I have installed it, but I cannot find the add-ins option in the toolbar above.
Okay, I'll just tell you what to do. Press Alt-T-I, Alt-T-I. And if you see that check, do you see this checked box? Real Excel, X real stats, do you see that option there?
Yes, sir.
So select it unselected, press OK. Unselected and press OK.
Okay, hold on.
Okay, then once again, once you press OK, again press Alt I and select it again. So you uncheck it and then you check it again. So now you should be able to see that add-in option over there.
Yes, I'm able to see.
Okay, should I repeat the step that I did?
Yes, sir.
Okay, so I go to add-ins, go to real statistics, data analysis tool, select regression, click on logistic and probability regression. I click on OK. I have to select the data which I have and I do fill. Are you with me till here?
Yes, sir, I did that.
Okay. The output range, make it new, otherwise your data will get replaced. Make it new, so you'll add a new sheet. Don't change anything else, just add a new sheet. Here, right, it'll click new and then press OK. Once you press OK, you should be seeing a new sheet with some amount of data, something there, some graphs, something which is there. Did you get some output? Yes, you see something like this, similar?
A bit different. Like the points on the y-axis are a bit less as compared to what you're getting present.
But you do see a graph, something like this, right?
Yes, I do see a graph.
Go to the right, go to the right. Do you see this classification table over here? This is what is important. Okay, you see this classification table? This tells you the accuracy is 88%. That there were 56 patients who had malignant prostate cancer and we correctly predicted that for 56. But out of those, we incorrectly predicted for 6. Do you see this table, classification table? What is the accuracy you see?
I see the accuracy as 1 and 0.
1 and 0. There's something wrong which you've done. I think you see 100% accuracy, is it? What is this number? 0.88. You see this number? What do you see?
I see the number as 0.062.
0.062. Okay, I think you've done.
0.62.
Okay, 0.62. So your accuracy is 62%. Okay, so there is something which is you've done something differently, possibly, which is why you're getting that different. Otherwise, mostly you should be getting the same answer. Okay, but this gives you a decent idea in terms of how this classification works. Okay, this is the key in terms of your probability. What is important? These two values which you see over here are the correct values. These have been correctly predicted. This 56 and 32 that have been correctly predicted. What you see over here, that has been incorrectly predicted. Okay. Now think of it in this way: a patient who does not have prostate cancer, and you tell that patient that you have prostate cancer. That patient, even if he does not have, I mean, he's completely all right, but just listening to that, he's going to fall sick. Okay, that is what is important to avoid your error. This is what you called as your error in terms of your false negatives or false positives. That is what you should try and reduce. Now the way to look at it, if you go at the bottom of this table, at the bottom of column A, you will find another table over here. And what is something which you need to look at is this column called as p-value. So I'm going to just select this, the column called as p-value. Basically what we have to look for is in all of this column, let me just use a different color. This entire column, this value should be less than 0.05, not greater than, less than. If the value is less than 0.05, it indicates that there is a strong relationship between these two values and predicting cancer, prostate cancer. And I'll explain that to you in Tableau. This p-value is important. If the value is less than 0.05, that means this value is significant in terms of your analysis, whatever you're trying to showcase. It indicates there is a very strong relationship between compactness and fractal dimension and your prostate cancer. That is what it really indicates. Okay, clear? Clear, folks? You got the idea?
Yes, sir.
Okay. So whatever data we clean, right, I'm adding it into a different sheet. I've just added it into a different sheet. Okay, just save the sheet and go to Tableau. You might have, I've kept it open for my benefit. I copied the data that we have cleaned, all these columns, in a different sheet. And what is important, we are going to look at compactness and fractal dimension. The two columns that is important to us, compactness and fractal dimension. Clear, everybody? I have just copied the data in a different sheet. Can you go to Tableau public now, or whatever version of Tableau you have installed? Let me know if you have Tableau public open. I'm not sure if I can solve this problem, by the way. Okay, does everybody have Tableau public open? Yes, folks. Do you have Tableau public? Can you guys hear me?
Yes, sir.
Okay. You have this open, Tableau Public or Tableau?
Yes, sir.
Okay, so here you should be seeing an option to connect to data. Okay, so click on Excel because you want to connect to the Excel sheet. So click on Excel, go to the file wherever you have kept it and select that data. So my system just got a little stuck. So on the left hand side, you'll see all the different sheets, and I'm going to drag the sheet that I want. That is, I've named it as PCAN001. I'm going to drag it over here on the right hand side. You can drag it or just double click it. And I should see the data being reflected at the bottom over here. Everybody has it this way?
Yes, sir.
At the bottom, right, you'll see three options. One is the sheet, one is the dashboard, one is the storyboard. Go to the sheet one. And we're going to take compactness and fractal dimension. That was the two fields, right? We had compactness and fractal dimension. So I'm going to take compactness, just double click compactness and double click fractal dimension. So you should see a dot like this. Just double click both those values, double click compactness, double click fractal dimension. Do you see a dot like this?
Yes, sir.
Once you see that dot, go to analysis and uncheck this aggregate measures. You see this aggregate measures, uncheck it, and you will see something like this. Let me know if you see something like this. Do you see this? Do you see something like this? Let me know if you want me to repeat the steps. Saurabh, how much time do we have left? Let me know if you see this graph, something like this.
So I do see a graph, but it's not as scattered as yours.
You've taken these two columns only, fractal dimension and compactness.
Yes, sir. I've taken those two columns.
Okay. No worries. So now what we have to do is you have to take diagnosis result and put it on color. I'm going to change the color, by the way. Once again, I'm going to use two colors. Yes. What I did was okay, this is something which you might see. This is what you see. So when you look at this graph, right, when you look at it over, you can actually make out that there is a small grouping. Based on the color, you can see the points which are across below this line, right? If I draw a, what do you say? If I draw a imaginary line like this, let's say if I take this, go over here. And if I draw an imaginary line like this, you can see the points below it are indicating 0. That means that is benign. The points above it is indicating malignant. So you can actually see the classification using this graph. Make sense? Make sense what I'm trying to say? So I'm going to explain one more concept before I think we are almost going to run out of time. I'm just going to quickly show one thing. I'm going to add a new data source. I'm going to load this COVID data and I'm going to show you a small analysis of this data. I'm going to do it a little quickly because we don't have that much time. Okay. So here I am going to drop this country and territory code. I'm going to drop the cases on color. Cases on size rather, color से ज़्यादा size. Okay. And size. I'm going to make some changes. As a running total, that is the total number of cases till now. And same over here. I'm just showing it to you quickly a little bit just to give you an idea. Okay. I'm going to put date onto pages. This date I'm going to change as month. Another week number. Let's go with week number. Okay. And let me just play this for you. You will see how the cases have grown by week. You see the cases, the size increasing every week. You see the timeline over here. You can see how the cases have really, shot out. Okay, if I look at it till this 22nd, right, you will see how the cases have just shot up across the globe. That's something which you can do with Tableau. You can even do a little bit of forecasting. If I add the date over here and I add the cases over here, I'm going to make this into a line. I'm going to make this as day and I'm going to choose a specific country. Okay, let's say I take India, IND. If I go to analytics and I add forecast over here, I can see the small forecast in the end. Okay, I can see that small forecast in the end over here, that it is indicating how well the cases are going to go now. It's going to go up and down a little bit. So this is something which you can do with Tableau. You can even do a little bit of forecasting. It's not that great based on what I have seen, but yes, it does give you an option. It does give you some level of option which you can use. Okay, I hope that gives you an idea. I wanted to talk about a couple of examples specifically around biology. Okay, so if you go to this website AI Cures, they had shared a lot of information when COVID started. What they do is, if you, I'm pretty sure you understand this, if you're from a bio background, you understand the smiles. What they had used was, they wanted to predict this water solubility of a particular compound. Okay, so what they have done is, this is dimethyl, whatnot, I cannot pronounce it, but this is the molecular formula for that, C5H12. So for this, what they're doing is, this is something you do as a test in the lab based on, for a particular molecule or compound, you test the water solubility. What they have done, there is a model called as SAMPN. You can check that out. There is a link for that same thing. What they do is, based on this molecular structure and the nodes and how they have incoming bonds and the bond index, mapping from a bond index to the index of the atom, all that they have used to predict the water solubility of this particular molecule. Okay, they've created an entire program is there, an entire module is there. It is called as SAMPN. You can actually, one second, I think I have it open. The paper is there over here. Self-attestation based message passing neural network. Okay, for predicting molecular lithosity and aqueous solubility. So if you read this paper, they have used analytics. They have used neural networks primarily to predict the water solubility, the aqueous solubility of a particular compound. That is what they were thinking of using for COVID as well. The other problem, which if you search for on DeepMind, you go to the site, one of the biggest challenges is to predict the protein structure, because of the size of the protein molecule. I mean, the size of the virus and everything, there is a protein, there is a folding problem which happens. Okay, I'm not a expert in biology or life sciences for that matter. There is a protein folding problem which, using DeepMind, Google's analytical tool, they have been able to kind of solve or give some kind of solution for that. I haven't read the entire paper, but this is something also you can read upon. I will share some of the videos of my session. If you want to understand analytics a little bit more, you can look at that. We talked about visualization. These are some of my books. If you want to understand healthcare IT, you can reference this book. This is available across on Amazon, on all Amazon websites globally. It's available on Kindle as well as hardcover. It might be easier to get the Kindle copy. This is another book on technology to business, which is talking about more about marketing and how you should really understand that just understanding the technology is not going to help. What you need to understand is the business. And this is something which I'm currently writing. When you look at data science, when you look at analytics, for somebody who does not understand it, it looks like magic. Okay, which is why I'm using simple language, simple experiences, literally from the aspect of cooking towards using a sorting hat to explain certain concepts. Okay, it will have limited mathematics, but it should give you a good idea in terms of how analytics really works, the basics. Okay, you should get an idea, and I am hoping it is more like a novel rather than a textbook. Okay, it is more like a book which anybody can pick up to understand some of the concepts. Okay, that's something which is coming up hopefully in the next 2 months. I am hopeful you are all awake. So any questions, folks? Do let me know. Any questions, folks? कोई विशेष टिप्पणी? Thank you. If you need any question, if you have any questions or doubts, I'm there in the group. I'm there in both the groups. You can definitely ask me any questions. I will be sharing a small chapter which you can read. It should be available only for 24 hours or so. You can read that and do share your feedback, how it reads. All right. Enjoy your sessions. Thank you so much.